So this is a 4 by 4 matrix, so that means there's going to be 4 vertices. So let's label that V1, V2, V3, and V4. Doesn't matter what order you're putting them in. Okay, so this says it's a directed graph. So this means there's one arrow from V1 to V1. Okay, that means it's a loop, right? Like that. All right, and then on this one here, there's one arrow from V1 to V3. So just make sure you put the arrow in. And then this says there's 2 arrows from V1 to V4. So 2 separate arrows like that. All right, let me erase here so I make sure I can see them all. Then I'm going to have 1 arrow from V2 to V3 and 2 arrows from V3 to V2. So that and that. Getting kind of messy. And then 1 arrow from V3 to V3. So that's a nice loop. And then 1 arrow between V3 and V4. And then this one here says 1 arrow from V4 to V1. Right there. And then, oops, I did that wrong. 1 arrow, V4, not V1, not V1. Trying to, I can't erase it without erasing everything. Okay, I'm sorry. This is 1 arrow from V4 to V2, like that. And then 1 arrow from V4 to V3. Crazy messy, right? Okay, so this is an undirected graph. And so I know I'm trying to make the matrix, the adjacency matrix. And so I'm looking at the vertex V1, and there's no arrow or loop to itself. So that entry is 1. There's 1 edge between V1 and V2. So that's a 1. There's no edges between V1 and V3. So that's a 0. And there's 1 edge between V1 and V4. Then we move on to V2. So V2 has a loop on itself, so that's 1. V2 has 1 edge from V2 to V1. V2 to V3 has 2 edges. And then V2 to V4 has 1 edge. Then there's no loop on V3. And so let me make this longer. Okay, there's no loop on V3. And V3 to V1, there's no, wait a second. I'm doing the wrong one again. Okay, so I'm doing V3 to V2. There's 2 edges there. And then V3 to V4, there's no edges. And V3 to V4, there's no edges. Okay, so that's a 0 as well. All right, so then we're going to vertex V4. It's got a loop, so there's a 1. And so that's V4 to V1, that's not a loop, but that edge. Okay, V4 to V2, that's 1. V4 to V3, that's a 0. And V4 to V4, that's the loop, and that's a 1. Okay, so then we did this. So it's the ijth position. So this is the number of walks from V2 to V2. So it's the ijth position. So we're looking for the 2 or the 2, 3. So A sub 2, 3, 2, 3. So that's 7. And then here we're looking for A sub 3, 1, and that's 11. And then since this is A squared, I'm looking for V3 to V2. So this is 5. Okay, so then on the next page where I did this in class. So let's finish this off with finding out the isomorphism, so matching the edges. So E1 is here, and it's connected with a a vertex of degree 3 and a vertex of degree 4. So I think E1 could be connected to F3 because F3 is connected to a vertex of degree 4 and vertex of degree 3. So it's not going to be unique, but this is one of the things we could do. So E2 is this edge right here between these 2 vertices of degree 3. So E2 looks like it matches with F1. And then E3, wait, we did it. No, I didn't do E3. So E3 looks like it goes to F2. E3 to F2 because it's doing the same thing, right? It's on the opposite side. Okay, let me just change colors. So now we're looking at the E4. So E4 goes between a vertex of degree 4 and degree 3. So that looks like it could be this right here, the 7, right? F7. And then E5 looks like E5 is right here, and it looks like it goes between a vertex of degree 2 and a degree 4. So E5 looks like it goes to like this one, degree 4 to degree 2. So E5 will go to F6. And then it's kind of process of elimination. We don't have too much left, right? So the E6 here is going to go to the F5. And the E7 goes to the F4. Okay,